Hello, today we're going to discuss 6.4, the fundamental theorem of calculus. In previous sections of this chapter, we introduced the two types of integrals, the indefinite integral and the definite integral. We know the indefinite integral is the family of all antiderivatives of a function, and the definite integral is the area on the curve. But we have not developed a scheme to evaluate definite integrals. In this section, we're going to talk about a very important theorem in calculus, the fundamental theorem of calculus, which connects the two types of integrals and also provides a strategy to evaluate definite integrals. So the theorem says, let small f continues on the closed interval from a to b, then the definite integral of small f from a to b is equal to capital F of b minus capital F of a, where capital F is any antiderivative of small f, that is capital F prime equals small f. In other words, in order to evaluate a definite integral, you just need to find the antiderivative of the integrand and then evaluate the antiderivative at the lower and upper limits of integration and subtract. And we know we can find the area of a region on the curve by using definite integrals. Let's just repeat the same example we did last time to find the area of the region on the graph of f equal to x squared on the interval from 0 to 1. We're going to use the fundamental theorem of calculus instead of going through the original definition. So what we need to do is just find the antiderivative of x squared, which we choose to be 1/3 x cubed. And then we plug in 1 and 0 in the antiderivative, and then subtract. So we get 1/3 times 1 cubed minus 1/3 times 0 cubed. And at the end, we get 1/3. So this is the same answer we obtained the last time. We can also use the definite integral as a measure of net change. Suppose you are given the derivative of a function f, then you can find the net change in this function over interval from a to b by integrating its derivative from a to b. And the derivative of the function is required to be continuous on this closed interval of a to b. So let's do an example. The management of state office equipment has determined that the daily marginal cost function associated with producing battery-operated pencil sharpeners is given by C prime equals 0.000006 x squared minus 0.006 x plus 4. So this is the marginal cost function, the derivative of the total cost. And this C prime is measured in dollars per unit, and X denotes the number of units produced. Management has also determined that the daily fixed cost incurred in producing these pencil sharpeners is $100. So this is the cost that needed even without producing anything. So find the stateless daily total cost for producing A, the first 500 units, and B, the 200 first through 400 units. So let's just use the formula for the net change in this problem. So C of B minus C of A equals the derivative, the integral of C prime from A to B, which is 0.000006 x squared minus 0.006 x plus 4 in this problem. So we just integrate this function term by term. From x squared, we get 1/3 x cubed, and from x, we get 1/2 x squared, and from 4, we get 4x. So we can do a little simplification of the result to get 0.000002 x cubed minus 0.003 x squared plus 4x, and then we just evaluate this function at the 2 points a and b and subtract. So in part A of the question, we just let A equal to 0 and B equals 500. So we get a C of 500 minus C of 0 equals 0.00002 times 500 cubed minus 0.003 times 500 squared plus 4 times 500 minus 0.00002 times 0 cubed minus 0.003 times 0 squared plus 4 times 0. So at the end, on the right side, we just got 1500. And also C of 0 is 100, as we already discussed. So then we can easily obtain C of 500 is 1600. So that's part A. Part B, we need to find the Stadler's daily total cost for producing the 200 first through 400 units. So we can calculate the first 200 units total cost and the first 400 units total cost and subtract them. So just plug in A equal to 200, B equals 400 and subtract the total cost. So we got a C of 400 minus C of 200 equals 0.00002 times 400 cubed minus 0.003 times 400 squared plus 4 times 400 minus 0.00002 times 200 cubed minus 0.003 times 200 squared plus 4 times 200. At the end, we got the 552. So that's the answer. This is the end for today.